Hey folks, so my name is Miles Berkey. I'm going to be presenting my master's, which is titled The Immensity of Minutiae, utilizing Bryophytes to detect an Ice Age Refugium in North Cascades. I'm at Western Washington University. My study site is called Barlow Pass. It is in the Cascade Mountains. It's about 60 miles northeast of Seattle, Washington, and about 100 miles southeast of Vancouver, BC. Barlow Pass itself has about 100 years of plant collections. There are some interesting northern taxa, and I'm basically asking the question of why they're there. There's a decent amount of geological evidence that the Cordilleran ice sheet didn't fully cover Barlow Pass. And so because of that, it was possibly ice-free during the last glacial maximum. And I'm wondering whether this place was an Ice Age refugium. So Ice Age refugia were ecologically stable areas because they were ice-free. They were largely isolated from the ice around them. Because of this, we see speciation events, so we see endemic taxa in these areas, and so they influence the trajectory of the evolution of northern taxa, and also we see glacial relics, so things that are of northern distribution today, but displaced down in the temperate areas as a result of glacial isolation 18,000 years ago. These areas are biodiversity rich. They have unique microclimates that are able to support species of cooler climates, and because of this, they might serve as Ice Age climate change refuges for species today intolerant of the changing climate. So the Bryophyte flora of Barlow Pass may be characteristic of other Ice Age refugium. This is kind of my working hypothesis. This is what I'm testing. The biogeography of the Bryophyte flora paired with the functional traits, say the ability to produce sporophytes and spores among these species I'm finding in Barlow Pass may, along with geomorphological evidence, show that Barlow Pass was an Ice Age refugium. To test this, I basically have developed a methodology where I'm developing the Bryophyte flora of Barlow Pass, and I'm also doing the same thing for similar sites but that were glaciated during the last glacial maximum. In doing this, I'm showing that through the species envelope similarities among these sites, microhabitat availability is not exclusive in Barlow Pass to support these glacial relics that I'm finding. Finally, I'm going to take the Bryophyte flora of Barlow Pass, and I'm going to compare it to other putative Ice Age refugia, such as Haida Gwaii and other Ice Age refugia in the Northern Hemisphere. So far, I have many of the same species in all my sites, about 262. Each site has rare species. There are no strong refugial or relics in my control sites. However, I have a couple in Barlow Pass that I'll talk about. So Sertonium hymenolophoides I found 2 years ago behind a waterfall. And doing some research, I found out that this thing is dioicous in North America, so we only see females. So really interesting. Along with the ability to not produce gemme, this thing has low dispersal potential. So and there's quite a bit of discussion in literature about where we see these things disjunct today are likely the result of establishment in a glacial refugium during the last glacial maximum. There's a lot to talk about here, but I'll just move along to the next one. Macrodiplophilum imbricatum. This one is a leafy liverwort with a distribution mostly in Beringia, but we see it trickling down the northwest coastline of North America. Haida Gwaii and northern Vancouver Island are where we see the closest populations, but down at the base of Big Four Mountain is where I found it 2 years ago. Salopilum levigatum. This is one of more northern Arctic distribution. It does produce sporophytes, so its placement in Barlow Pass, I cannot definitively say that it is the result of an Ice Age refugium, but it's unique, it's rare, it's disjunct, it's really fascinating. Finally, I did a bit of geomorphological work to really show where the glaciers were in this valley. I developed the Paleo-Alpine glaciers, which are these hashed-marked areas on the map, and then the Cordilleran ice sheets coming up the valley shows that there was likely a proglacial lake established, and maybe on the margins of this lake was suitable habitat for some of these Arctic species. Finally, I just want to say that's it in a nutshell. If you have any more questions, reach out to me. Special thanks to the IAB for funding me in this project and many other people that have helped me.